Problem 11. Claire adds the degree measures of the interior angles of a convex polygon, so it's like pointing outwards like this. It's not going to be like that. That's a concave. And arrives at a sum of 2017, and she discovers that she forgot to include one angle. What is the degree measure of the forgotten angle? So your sum, okay, for any question that you deal with, always relate it to given information. And since this is my first time doing it with you guys, I'm going to think of the convex polygon. When you sum angles in a convex polygon, there's a very special trick to understand what the interior sum is going to be. Let's say I have this hypothetical shape, right? How do I know the sum of the interior angles very quickly? Well, I draw as many triangles as I can. And if I were to do that, I realize that I have how many triangles? I have 1, 2, 3, 4, 5, 6. So the interior angles, the sum of the interior angles is going to be equal to 180 times 6, which is 1080 degrees. So the reason why I do this is because we know the special shape of a triangle. The sum of the interior angles is always going to be 180 for a triangle. So if we have 6 triangles, then the sum of all these angles, right, is going to add up to the ultimate interior angle, the sum of the interior angles of this entire shape. So that means the number of triangles we have would dictate the interior angle sum. So therefore, we want to relate it to this given information. Now, we don't know how many sides there are, right? Notice here, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides and I produce 6 triangles. But how can I relate that to this question? Well, let's not try to relate the 6 with the number of sides, because I don't think there's going to be like a very good method. But actually you can, right? Because for a triangle it's 180 times 1, because we have 1, and then for that, so we might think that it's actually n minus 2 times 180, right? Because n stands for number of side lengths. But we're not trying to find the number of side lengths here, we're trying to find the degree measure of the forgotten angle, so we cannot relate it to this information. Let's try to relate it to this. What is the closest number that 2017 is to a multiple of 180? Well, think about 180, for example, times 10. That's 1800. Think about 180 times 20. That is going to be 3600. So it's going to be n is going to be somewhere between 10 and 20. Let's reduce our search range to 15. 15 times 180, what is that? Well, 1815, right? That's going to be 19, so 270. So it's going to be 2700. So it has to be actually within 10 and 15. Let's try the midpoint. 12 times 180. 12 times 180, what? 1812, 316, 18. That's 2160. So we are getting very close. That's when it's 12. So it's between 10 and 12. What about 11? Well, 180 times 11, right, is going to be equal to 1818, 1980. So it has to be, not 11, it has to be 12, right? It has to be 12 to get our number, and the 12 is going to give us 2160. So 2160 is our closest number that's larger than 2017, that's also a multiple of 180 times n. So the missing angle must be 2160 minus 2017 to satisfy this theorem, which is that all sum of interior angles is equal to 180 times some constant. But it doesn't matter what that constant is, we're just trying to find the missing angle here. So this is equal to 2160, 2017, 3, 4, and then 1. So 143 degrees, and that means your final answer will be answer choice D.